All right, so let's look at another example of solving a two equation systems using matrices. So these are the equations we're looking at. And again, the first thing that we want to do when we're trying to solve this system is to write it in its matrices form in as an augmented matrix. So the first row in my matrix, in my matrices, is going to come from the coefficients and that value there on the right side of the equal sign. So my matrix is going to look like a -2, 1, -3. The -2 and the 1 come from the variables x and y, and the -3 comes from this part of the equation. The second row in my system comes from these values. So I have a 1, -4, and a -2. And this is my 2-row, 3-column matrices that I want to now simplify. Remember, this is called my augmented matrix. We always want to start by getting a 1 up here in this top left corner. And I can do that easily using a row swap with this particular problem as well. So I am going to swap row 1 and row 2. And that's going to give me a new matrices that looks like 1, -4, -2, -2, 1, -3. So I have a 1 up here in this position, so I'm just going to highlight that that was the place we wanted it to be. The next thing I want to do now that I have a 1 here is I want to put a 0 right under it. And so anytime I want to get a 0, that's going to be a multiply-add concept. That's the operation I want to do, multiply and add. So I am going to multiply row 1 by some number. I am adding to row 1, and it's going to be a new row 2 that I'm creating. So this is the part I want it to become a 0. So I'm going to multiply row 1, add it to row 2 to create a brand new row 2. So I have to multiply row 1 by 2 so that when I add it to -2, I get 0. So that's how I figure out what I want to multiply it by. So it's 2 times row 1 plus row 2 gives me the new row 2. So I'm always multiplying and adding to the row I want to change. So this is going to look like row number 1 is going to stay the same, right? We're not doing anything to row 1, so we'll just rewrite it so I don't get confused. 1, -4, -2. Now it's row 2 that I'm changing. So I'm going to multiply this value by 2 plus -2 is a 0. So then we go back. -4 times 2, which would be -8. Plus 1 would be -7. And finally, -2 times 2 would be -4. -4 plus a -3 would be a -7. And that is my new row 2 that I created. The next number we want to look at is this one right here. I need this to be a 1. Okay, so anytime I want to turn something into a 1, I'm typically going to be multiplying by the reciprocal. So the reciprocal of 7, or -7, the reciprocal of -7 would be -1/7. So I'm going to multiply row 2 by -1/7 to give me my new row 2. And when I do that, again, row 1 is not changing for me yet. 1, -4, -2. Now, 0 times 1/7 is still 0, which is good because, again, I wanted it to be a 0 here. -7 times -1/7 is a positive 1. And -7 times -1/7 again is a positive 1. So I have this new matrices here with zeros along the diagonal and a 1 here. The last piece I need to change is right above that. This is going to become a 0 as well. And just like over here, when we multiply and add something to get the 0, that's what I'm going to do. That's the operation I'm going to call for here. When we multiply and add, we always are doing it to the row I want to change. Okay, so I'm going to multiply row 2, add it to row 1 to get the new row 1. And I would have to multiply, because this number is what's going to have to add, or this cell is going to have to add with this cell in order to give me a 0. So 4 plus a negative 4 is going to be 0. That's how I know what I want to do. So I'm going to multiply row number 2 here by a positive 4, add it to row number 1 to give me a new row number 1. So we'll just kind of come down here and rewrite our matrices down here. So 4 times 0 is 0, plus 1 is still a 1. 4 times 1 is 4, plus a negative 4 would be 0. And 4 times 1 is 4, plus a negative 2 would be positive 2. And the second row stayed the same. And that is my new matrix after that operation. Now notice that I now have 1s along the diagonal, 0s above and below, and I am at my solution matrix at this point. That tells me then that these two values in the rightmost column are the solutions to my problem. So x is equal to 2 and y is equal to a 1. And those are the values for my solution. You can see it written like this. You might even see it written as an ordered pair 2, 1, because what do we have happening here? Remember that if we're talking about a systems of equation, we learned in the previous section that a solution to my system is where the lines or the functions actually intersect. And so they're intersecting at this point 2, 1. And this is, again, another example of how we would solve this system using matrices.